welcome back. Today we have a special guest from Austin, Texas. Howdy, Jimmy. How are you?
Howdy, y'all.
So we kind of travel back in time. It's early morning in Texas, and I hope this Friday, the 13th, will treat you good. And today we're going to hear your presentation about effective microservice communication and conversational patterns. Jimmy, what are three main things people will learn after your presentation?
Oh, sure. Number one, that we can use real life metaphors to design distributed systems. Number two, that the constraints of the real world are the same we see in distributed systems. And the third one is, even though everything has gotten much, much faster in building distributed systems, that latency and communication is much quicker, the same constraints from the real world apply to our distributed systems. And so we can apply those metaphors to design our distributed systems as well. Microservices,
Okay.
yes, microservices.
Okay, good. One more last question, which is very, very off topic. When I was little, I used to play those games with the cards, with the cars, where you have to drive. And there is a Austin circuit. Do you still have this? You know, the Formula One?
Yes, we do have it. We do have the
This
F1
is
race.
an awful track to go with because it has so many, turns. And how do you manage that?
I have no idea because it's so expensive to go to one of those things.
Well, you
I've
can
never actually seen it. That's
virtually
true.
do that. Okay, Jimmy, you are our last presenter at this Pink Floyd stage. Last question, also off topic. How about Pink Floyd? Do you like them?
I am a fan of Pink Floyd. Yes, I do like them.
Okay, good. So let's rock and roll this stage, and the virtual stage is all yours. Give us the information you have.
All right, thank you so much. Yes, so my name is Jimmy Bogard. You can find me on Twitter at @jbogard. And this presentation is on my GitHub at github.com/jbogard. And you can find me blogging about this topic and a lot of others on my blog at jimmybogard.com. My day job is independent software where I work with organizations building these kinds of systems, building distributed systems, building microservice-based systems. And one of the reasons I'm giving this talk is because a lot of the times that I go out to organizations to talk about like what's going wrong with their microservice architecture, why are they getting frustrated, or why is it just not working? And one of the things I've found is that when they're building distributed systems with microservices, which you are building distributed systems when you're building microservices, these things have to talk to each other somehow, is that they're not building these systems with a kind of metaphor in mind of how to design and how to have these systems communicate with each other. And so over the years, I've found that if I can kind of center myself and center my design thinking in a metaphor-based design, then I have a much higher probability of success in building these distributed systems with microservices. But before we get too far, I wanted to ground ourselves and talk about what a microservice is. Now, I used to joke that microservices didn't have a really good definition, and that was true. In the first microservices book, the definition was something like, a microservice is a service that is small and does one thing well. And that's a lot of opinions in there. It's very subjective about what small means, what is one thing, and what does it mean to do something well. Well, in the latest microservice book, there's a whole chapter in really defining what microservices are. So it's much more well-defined than it used to be. So I'm just going to take the definition out of that book and expand that a little bit. So in the latest microservice book, which is actually down there, Monolith to Microservices, it describes microservices as an independently deployable service modeled around a business domain. And it's an opinionated architecture. So it has a lot of opinions about how you should draw service boundaries, how things should communicate with each other. It also has a design focus towards smaller boundaries versus larger boundaries. So rather than trying to precisely define what micro means, instead we can really focus on what a service is. And that's really taken from decades of defining what services are. And then this is really trying to put a lot of opinions on there to hopefully get us into a kind of pit of success for building a service-oriented architecture. Now, even with all the definitions around it, all the patterns and things defined around here, I still see a lot of teams really struggle with building these kinds of architectures. And it's not necessarily like the micro is hard. It's easy to build small things. What's really difficult is trying to build things that talk to each other effectively. Because it's one thing to say, we're just going to build this microservice that lives on its own. It just kind of lives by itself. I mean, that's easy, right? That's like me going out and living in the middle of the woods and just like living off the land. Like I don't have to talk to anybody, and life is pretty simple, which is not unlike I guess how we are now with COVID. But it's when we have to actually interact with other people that things become a lot more complicated. The same thing with service-oriented architectures and microservices. As soon as these things have to talk to each other, we have to decide what is the nature of that communication? How are they going to talk to each other? How are they going to organize the work that's getting done? And who is in charge of all this? So in order to achieve that communication goal of having these things talk to each other, we need to have some kind of design patterns and guidelines of how things should interact. Now, a lot of organizations try to simplify this. They just say, well, communication is hard, so why don't we simplify things by just having everything talking via one way of communicating? And I see organizations kind of either one side or the other. They say that everything is going to be like synchronous web services or gRPC, whatever, where everything just talks directly to each other. And the idea is that that simplifies things because I now can kind of focus on one way of communicating, and I can optimize that path. I can optimize my tooling around it, my development, my deployment. Everything can be focused on that. But in the real world, we would see problems with everyone only talking via synchronous communication verbally all the time. The same thing with doing async messaging. I see a lot of organizations as well saying, well, we don't want all the kind of coupling that may come from synchronous communication, so everything is a message. But again, in the real world, if you had to communicate everything via something written down, some things would be very difficult to do. So I find a balanced approach is really the most appropriate of synchronous and asynchronous communication. And then the question is, well, how do you decide which way to go? And so that's really where I look towards the real world to see how the real world has solved these distributed systems problems and try to apply a lot of the lessons learned from the real world into our systems. So I want to look at some real life examples of people and real people systems using messaging to solve problems. And if you look in the past, like just past like computers and technology and networking, there were large scale distributed systems in the world. You think about things like restaurants, like large fast food restaurants or mail order catalogs. These are things that started off small and it had to scale up to be very large without a lot of technology, especially technology of individual systems communicating with each other. So if you look at those systems that already had to solve a lot of these latency problems and bad communication and drop messages, look at how those systems solved those problems. I can look at modern systems and see exact parallels between those systems and the distributed systems that we use on a daily basis. So I'm from Austin, Texas. And for those of you who don't know, Austin is the capital of Texas. And like most capitals of states in the United States, it's a little bit more kind of hipster sort of state, a city, where the rest of the state is really not that hipster. So that means we have a lot of hipster kind of things, like food trucks. So food trucks in the States, in my city in particular, are very popular. And the reason why they're so popular is because they have really good food that they drive right to you, especially to your office, and then you can go out during lunch and have a nice meal. So the reason why they're hipster too is they usually like fusion two things together. So one of my favorite ones that I go to is it comes out every Monday, and this one does hot dogs. No, it's not any kind of hot dog. They take the hot dog, they wrap it in bacon, and then they deep fry it. So probably not the healthiest for you, but it's absolutely delicious. And then the fusion part is they make the ingredients based on different kinds of cuisines. So there's a Vietnamese style hot dog, there's a barbecue style hot dog, there's a Korean style hot dog, and then they have fun with the name. So the Korean style hot dog with kimchi on top is known as the Kim Dog Il. Ridiculous. So one of the things I noticed about this system is that it has a lot of constraints associated with it, because this one food truck has just one person doing every single job. So in this food truck, it's just one person doing everything. Every single interaction is synchronous, and also every single interaction is in process. So when I go and order something, I walk up to the counter. When I order something, they ask me what I want. I tell them what I order. They say how much it's going to cost. I give them the money, and then I just stay right there. I don't move. I don't budge. And then that person goes back to the back of the restaurant, which is literally just like turning this way a little bit. They prepare the food right there, and then when they're done preparing, they give it to me, and then that's when I leave, and they can go on to the next person. So everything's in process, everything's synchronous, everything's done by one person. This actually sounds like a lot of the systems that I've built earlier in my career, and that I have a kind of like interior architecture, but it's still one single application, one single process. And so one single thread handles all of the different steps in the process for every single interaction I do with this application. So I view items in a catalog, I add items to the cart, I go check out, I go place my order. Everything is done by one single thread, one single process. And so it very much mirrors this kind of single process system of that food truck. Now, food trucks, even though they seem like it seems like not very much to get up and going, actually very expensive to build these things out and to get them licensed. So it could be a very large upfront investment. And so I've heard everything between 50 and 100,000 US dollars to build out your truck, to convert a delivery truck into a food truck, and then to get all the appropriate licensing to say that this is a place that can actually serve food in a way that's safe and clean and all that sort of things. So if I am a business owner or prospective business owner, I want to start this new business, then I have to figure out my business model to make sure that I can take enough orders in a day to be able to pay for that very large upfront investment. So what I can do is say, well, in order to figure out like how much money I can make at a given, in a day, then I really need to figure out like what's the maximum number of orders per hour, and then kind of maybe work out into an average number of orders. And so if I look at how many orders can I take in a given period of time, I need to figure out, well, how long does each individual order take? So we break this down in a bit of business model and say, let's take all the individual steps one by one and say, how long does it take to do each individual step? And if I add up all the steps and all the time it takes, then I have how long it takes to place a single order, divide that by how long I'm intended to be open, and then have a rough idea of how many orders I can take. So in this case, and I'm, by the way, totally making this up, I have taking order takes 30 seconds, dressing it up, putting the items on the whatever takes 10 seconds, grilling takes 100 seconds, and packing takes another 10 seconds to deliver it to the customer at the end. Completely made up. 2.5 minutes is probably generous in the amount of time that it takes. But what that means with 2.5 minutes per order, dividing that out, it would be 24 orders per hour. So if I have a business owner, I say, well, 24 orders an hour times X much dollars per business or per transaction, that looks like it's pretty good. But there's some further complications. This is a very kind of idealized model of interactions and all the different steps that happen. So some of the complications we'll see don't actually enjoy waiting in queues. I guess some cultures do. I make a joke in the UK that they don't mind waiting in queues, but a lot of cultures don't, and I don't really particularly enjoy waiting as well. Even though I can just, I guess, stare at my phone for 10 minutes, whatever. But I'm hungry though, so I know that if I'm waiting in line for food, then I have to wait for my food. So that means that when someone comes up and they see a long line, then people walk away. Because there's a couple reasons. One is we can't assume a constant rate of flow. That is, I say I have one order coming in every 2 minutes, whatever. does not mean that one person shows up every 2 minutes like lemmings or something. People aren't like that. I know that when I was still working in the office, seems like a decade ago now, that I would, right, like specific points in the day, I'd say, 11:45, 12 o'clock, 12:30. I go on Slack and say, hey, anyone want to go to get a food truck? In fact, we actually had a Slack bot command. It's a Slack bot food truck, and it would tell me the food truck of the day. And that'd be kind of everyone's signal to say, if you want to go get some food from the food truck, let's meet at the elevator in 5 minutes and then go down from there. So it wouldn't just be like one person showing up every 2 minutes. It'd be packs of like 4, 5, even 10 people showing up all at once to get their food. So if I was unlucky enough to arrive after that big group of people, all waiting in line, I was like, well, I guess I'll get something else today. And that's just human nature. We can't put like rate limiters and governors on the door to say, okay, one person every 2 minutes coming out here, so you got to wait in the lobby or something. That's just not how that's not how these systems work. So when someone comes here and says, long line, I don't want to wait anymore, they're gonna go on their app and order Uber Eats or something like that and say, I don't want to wait in line, I'll just go somewhere else. And so the business owner sees this, and what they're seeing though is not a customer leaving. They're seeing money they're losing because that person had intended to buy from them, but because of the unoptimized process of their orders, the person left, and therefore we don't get their money. So how can we solve this? Well, we can scale up and just say, let's just have 2 food trucks, or make the food truck twice as big or something like that. But we can't do that, right? This is a very difficult to change resource. And on top of that, won't necessarily help the throughput problem. If I just make the food truck bigger, I can't process necessarily more orders at the same time. If I have 2 food trucks, well, that's a huge upfront investment of another $50,000 to $100,000 US to be able to have that second food truck. And that's something you never ever see. Like I don't walk around town and see, oh, look at that, that awesome brisket food truck, taco food truck. And like, the line's like, oh, look, there's one exactly like it right next door. And that's just because there's too much of that upfront investment. So the solution that people come up with, seems very obvious, is to not make the food truck bigger or make more food trucks. It's to hire more workers so that I can divide and conquer the job. So instead of having one person do every job, I have each person doing exactly one job. And what that lets us do is have each job optimize their own work independent of the other. Because some items, some jobs, I can have more things done at once. So in the previous, just one person doing everything, well, that person didn't want to grill a whole bunch of stuff at once because they're talking to someone and something's on fire, so they have to stop talking to someone to put the fire out. Instead, if I have one person just focusing on that one task, then they can optimize that one task without worrying about how it affects other folks in the process. So at this point, if I say, what is my maximum number of orders per hour, so to speak, then really I look at how many orders can I accept. Because once someone has given me their money, they're much less likely to leave and go somewhere else to get some other food. I mean, it does happen. We may have to account for that. But once I've given someone my money, I want what I ordered. But if I haven't given them my money, there's no commitment for me as a buyer, and so I can go somewhere else. So it means that if I want to figure out how many orders I can do in an hour, it's really how many orders can I accept and take in an hour. And so if I divide that, I don't know, it was like 20 seconds or 10 seconds or whatever it was, or no, it's 30 seconds, then I could say the maximum number of orders that I can potentially fulfill. I have to figure out the back end as well. The maximum number of orders I can potentially fill went from 24 to 30 to now 120 orders per hour. So at this point, my numbers are looking really great. However, I've introduced a complication here, and that's where once there was one little circle, now I have 4 individual circles. And so I have to figure out how I'm going to fulfill the order based on now having to communicate with these other people. Now, I admit I'm actually a fan of not the super trashy reality shows, but one step above. And we have one in the States called Bar Rescue. And they usually get someone that's very angry a lot to do these sort of shows because it's fun to see someone yelling at idiots. And so in this show, Bar Rescue, he goes into a pub or bar or something that's losing money and not working out, and he goes in and figures out why are they not working? Why are they not making any money? And inevitably, the problem is they don't have a good system of communication of how to take and process orders. And so that's what we want to do with our systems, because we have to actually program how things are going to communicate with each other. We have to design a good way of interaction between all these different components to make sure that we can process orders effectively. So that's what we have to figure out now, is how do we process an individual order? The transaction is no longer synchronous. So in the first interior architecture style picture, when I go up and place an order, I stay and I don't move until I've actually received my food. So that's kind of traditional ACID style transaction. I stand there and I don't move, and it either succeeds or fails based on this interaction. But in this picture, the transaction is no longer synchronous. It's now a long-lived transaction. We also have to figure out, how do later steps know what to do? Are they just kind of like eavesdropping in and what's getting ordered? Or is there some way that the orderer, the person in the front, the cashier, is communicating to the back end, here's what is ordered, and here's what's coming up next? We also need to figure out how we know when we're done. So how do we know we've actually completed all the items in the order, and how do we then deliver that order to the end user? And the solution here, surprise, surprise, is going to be messaging, communication patterns, and conversation patterns. So what I'd like to do is take each of these interactions one by one and figure out what is the most appropriate means of communication between each of these different interactions. By the way, I actually worked in fast food, so I do have a little bit of insight. This is my coffee mug from from working there. So I do have a little bit of insight into how these systems actually work. So I'm not completely blowing smoke here. So first interaction, placing an order. So imagine yourself going into a fast food restaurant or or a food truck, and think about how you communicated that order to the end user or to the cashier. What information did you communicate to them, and what information do they communicate back? So thinking back, like if I'm going and placing an order, I have to tell them what food I want. They need to know how to notify me that my order is actually ready. And the final thing we have to figure out is, should we make this interaction asynchronous or synchronous? That is, do we have these two people standing and directly talking to each other, or is it more of an asynchronous communication where I write something down and I pass it over the counter to the other person, and sometime later they pick it up and they read it, and then they place my order. So in all the interactions that I can really think of when I'm going into a restaurant, this is a synchronous interaction, this initial placing order interaction. In this case, the cashier and the customer are blocked, not doing anything else during this interaction. And in fact, you get annoyed, right? Like if you're in line placing order and you see the person in front of you is on their phone, not paying attention, you get annoyed. So ideally, like both people are not doing anything else. They're just focused on this one conversation. We also notice that it's not a durable form of communication. That is, we don't write anything down when I'm talking from the customer to the cashier. It's completely verbal, which means that nothing's written down, and the cashier isn't listening, or I'm not listening. That message is lost. However, it's a very fast form of communication. So the order taker and the orderer can go back and forth very quickly because there's not a lot of overhead in that communication. And the reason why we're doing this, having a non-durable form of communication, is because there's very little overhead in being able to place these orders, which means that this line can go down very quickly when I have very little overhead in this communication. So translating this into kind of a virtual computing system, what is a synchronous, non-durable form of communication that we could use to be able to have this first interaction? And the one I reach to almost all the time is going to be HTTP. HTTP is a synchronous form of communication, and that the sender is blocked waiting for a response. Now, we do have things like async await to kind of free up resources to do other things, but if you look at the control flow execution, even though I may await the call, like I'm not moving down to the next set of code until I receive a notification that the response is received, and then I can go on. So my control is blocked until I receive the response from the server saying, here's the result of your order. So in this case, I've got a post to a web service endpoint saying, here's my name, here's the item I want. And it gives me a response saying, yep, I've got your order. And here's a little breadcrumb that I will give you to be able to see the status of your order or review the rest of the details. So some of the patterns we can see here, one, it's a synchronous request response between the individual talking and the server. So it's a synchronous call and it's request response. I make a request, I get a response. And they're actually giving a little breadcrumb saying, here's some more information about your order. And that's also known as the claim check pattern, where I leave a little bit of information to the person calling me to say, here's some information for you to come back later to see, here's the status of your order. Okay, so that was kind of the simple one. What about all of the other subsequent interactions? How do we manage the communication to like the quote back end, the set of services or people that the customer doesn't interact with directly? They only interact with the cashier. They don't interact with any of the other steps in the back end. But something has to manage those different steps in the back end. So we have to decide, should each of these communications be durable or non-durable? Should they be synchronous or asynchronous? Who manages all the different steps? How do we know when we're done with each of these steps? How do we manage the failures? So if one of these things fails, how do we recover from those failures in a way that still makes the customer happy? So let's just try one of these out. So I have the cashier and the person doing the initial dressing of the order. And so let's just try out synchronous request response and see how it goes. By the way, this is the exact exercise I do with on clients and customers. And we just get in a room, we whiteboard, we kind of draw out our services, and then we start to look at the communication and try out different means of communication to see what makes the most sense and what provides the kind of best total experience for the end user. So this one, we've got synchronous communication from the cashier to the first kind of backend service. So we could try just another web service, right? Hey, I want you to address the order. Here's the URL to the order that I want you to address. And the dress person says, got it. Okay, I've done it. But what happens if they don't? Like, what if they're actually doing the work that I've told them to do previously? And like, I can't do this. I'm busy right now. And so we still have to receive a response on the client side. We don't just wait forever. So instead we get something like service unavailable 503 because it's busy doing other stuff. Well, I still need to have something actually made for the customer. So, I'm going to try it again. Okay, well, that didn't work the first time. So let's try this again. I need you to place the order. Pretty please with a cherry on top this time. Now, like maybe it takes 2 or 3 times before the dress person actually hears me and say, okay, now I can do it. And now we have to worry about, well, if I yelled at them twice, and the first time I didn't get a response. Say, hey, I need you to make this order. No response. Okay, I guess they're busy. Hey, I need you to make this order. Maybe louder this time. I have to worry about, in this case, just because I didn't receive a response the first time, that doesn't necessarily mean that the person didn't hear me. It just could have meant that I didn't wait long enough to get that response to say that they actually got the order and they processed it. So now in this case, person has to figure out, like, was that the same order as before, or is this a different order than we had before? Not sure. So we can improve on this a little bit and saying that initially in this synchronous communication, we were having that person actually do the work when I told them to do it. But instead of them doing the work now, we could have them do the work later. And HTTP actually allows for this in a separate response code in the 202 accepted. So this is more of a fire and forget, where I say, hey, I need you to do the work. And they say, yep, I got it. Good to go. And that way they don't have to do quite as much work up front in order to be able to process the order. Now, I actually see a number of restaurants do this. But whenever I see this, it worries me as a customer because I see them just kind of yelling at each other all the time. And I wonder, like, how do they get anything done if they're just yelling at each other and people forgetting stuff? Because this relies on everyone's memory in order to be able to process this whole order. So in real life, we don't really see a lot of yelling in restaurants. I mean, you see a lot of yelling, you know something's wrong. Instead, what we see is people write things down. And that was one of the things I took away from those kind of semi-trashy reality shows around restaurants and bars, is one of the things they do immediately when they come in is they put in some form of written communication to ensure that people don't forget things and the customer gets upset. Even though it adds a little bit of overhead, it makes everything run smoothly and the customer is happier at the end, which means they're going to come back. So in Texas, we got this burger place called Mighty Fine, and you can actually see the ordering process in the bag on which you order on. So when I go up to the cashier's desk, the counter, this bag down, and this bag has all the different things you can order on it. It's a very simple, very simple menu. So it's just burgers, French fries, and that's hot dogs, I guess. And that's about it. And so when they ask me what I'm ordering, they actually circle the things that I order on that bag. And it's upside down. So like I write my name on it and I give it to them and they're circling the things as I go. So what they can do is as I order different things, they can decide how this order should actually flow through the system. And so instead of them yelling at everybody, order up, you're trying to place this order. Instead, what they're doing is actually physically passing this bag around to each of the appropriate stations in order for the order to get processed. So as the order flows through the system, it's really the bag flowing through the system. And if I look in communication patterns, this is actually known as a routing slip. A routing slip is a durable form of communication. So it's a message that actually, a durable message that flows through the system. And that message is special. It has the instructions of what the order information is, what the order contains, and it actually includes a list of steps for this order to be processed. So in the previous picture, if I didn't order French fries, for example, it would not have the FF circled. And so what that means was we didn't have to pass that bag to the fry station if the customer didn't order fries. So we can actually skip that entire step and go straight to deliver that order to the customer. So in this simplified ordering process, we can decide all the steps that need to be fulfilled in the order that they need to be fulfilled when the customer actually places the order. Furthermore, we're going to have asynchronous communication. So each individual station manages their own backlog of work. And so as the orders flow through the system, as each step completes each step of the process, then they're going to take that bag and pass it over to the next step. And then that bag just goes at the end of the line in a line and a queue of bags that represents the queue of work that needs to be done. And so as each step does its work, it pushes the bags down and just a first in, first out queue. First in, first out, first in, first out. Yes, first in, first out. Yes. FIFO queue that they manage and just push the bags down as they go. So what that means is I don't actually have to have any kind of verbal communication between each of these individual steps. So I don't have to worry about the grill person is busy grilling. So, I have to wait for them to be grilling their step to tell them another order. Instead, all I do is go and place my bag, my message at the end of their queue, and then I can go back and do the rest of my work. So that means that we provide a bit of decoupling between each of these steps. Because these are asynchronous durable messages, this gives us temporal decoupling. So I'm not worried about the time it takes for the other person to receive or process the message. All I'm doing from a previous step is dropping a bag on their station. So this is a kind of a simplified view, though. A lot of the restaurants that I see in the real world are much more complex than this. So this very simplified routing slip sort of communication behavior works really well if I have a simple menu with a simple fulfillment process. Anytime things get any more complicated, I'm going to have something more complex to be able to manage it. So that's what I do. Let's go ahead and turn this up to 11 and see what it would take to scale a more complex restaurant. And a good example is McDonald's. Now, I will admit, I have been to a McDonald's in Vilnius, the one that's on the main thoroughfare that has a walk-up drive-through window. So I've been able to see this in action in other countries as well. So McDonald's is a restaurant that actually started out very much like the previous restaurant we looked at. Very simplified menu, very much a kind of a assembly line process where everything flows through in this exact order, which worked for a very long time for this restaurant, McDonald's. But as customers became more sophisticated, I guess, and wanted more interesting things and there's more competition, then McDonald's had to try to differentiate themselves and couldn't just be like assembly line hamburgers that sat under a heating lamp for 10 minutes, 30 minutes, an hour, whatever. So that meant that for McDonald's, they still wanted to have orders being given to you as quickly as possible, right? There still wanted to be fast food or whatever the right way to call it is, fast casual or whatever it's called today. They were still going to be or giving your food to you quickly, but they wanted to have a lot more variety in their menu. So not just have one kind of thing, but have a lot of different kind of things. So in order to achieve a more complex menu with a lot more options available for each item that I can customize, that means that I have to change how this overall process worked. And I have to have each of these individual stations be a lot more independent. And so that's what you see that in a modern kind of fast food restaurant, that a lot of the individual food stations are wholly independent of each other, but not always. Like sometimes you do have sometimes we do have some dependencies between steps, but only for specific orders. If I go in and order a fried chicken sandwich or chicken, whatever McChicken, whatever it's called, but it's a sandwich with something fried on it. That means there's a dependency between two steps, between the fryer and the grill. So there are sometimes dependencies, sometimes not. And the steps also vary per order. So it's not always like the same thing. I could come up and just order French fries, or I could just order a hamburger, or I could order a lot of different things all at once, or just a shake or whatever it might be. So every order has to be treated as different than the other. And I cannot rely on just a simple routing slip in order to process the orders, because it will still be too inefficient. So many things can be done in parallel. So we have a little bit different form of communication. So how do we manage this? Well, let's first look, like I always do, at the very first step of the process, where they take our order. And so for this interaction, we'd actually still preserve the synchronous process. And the reason why I want to preserve this is because, again, the maximum number of orders I can take in I can process is limited by the number of orders I can take in an hour. So I still want to have a very fast form of communication between the cashier and the customer. Now, obviously, this has gotten more sophisticated. Like you can order McDonald's on your phone, I think, these days. And they have those kiosks as well. Like you can go, instead of talking to a person, you can go place your order on this kiosk. Although I don't know how often they clean those things, so I'd probably not use those these days. But it's still, you placing the order is still a synchronous operation. It's just maybe delivered asynchronously. So the first interaction, still going to be synchronous. Now the complication comes in. How do we process the order? Well, we knew from even our simple example that a synchronous form of communication is just impossible. There's just no way that would possibly work. To have the cashier like going and physically talking to each individual person to get something done, that's impossible. A routing slip's going to be a little bit too inefficient because certain steps can be done in parallel and out of order. And by having an assembly line routing slip, even though I can skip individual steps, it's going to be too inefficient because I have to still process the order when it's received after the previous step has been completed. So this solution is going to be a conversation pattern. So this is going to be a more complex communication pattern that involves multiple interactions between different services to achieve an overall end transaction to the customer. So how does this work in the real life? Well, in the real life, if I want to have multiple steps be able to be processed in parallel, then that's going to be more of a pub-sub kind of communication, which I notify multiple services and multiple stations that an order has been received, and that each individual station can then start its order when that order has been received. So I can publish a message saying order's been created, and the contents of that message are going to be then, here's the information about the order, and then now I can have the grill station start at the same time potentially as the fire station, because those two steps are mostly independent of each other. Now, there's a complication here though, that when I have different steps executing potentially in parallel and out of order, now I have the problem of how do I know when the thing is done? In the previous routing slip communication, I knew the order was done when it got to the last step. It just goes one by one by one by one, gets to the end, and now I give it to the customer. In this case, I can and will have individual stations completing before the other or after the other, really depending on the order. and I don't know which ones are going to necessarily complete first. So how does McDonald's do this? Well, you may not have noticed this, but right after you order, well, first they ask you, is this for here or takeaway? And that question tells them how exactly they're going to track the completion of the order. If you say it's for eating in, then what they'll do is they'll place a tray on this counter to the next one. This kind of wide counter that has your order as well as other people's orders on it. And if you say takeaway, then it won't be a tray, it'll be a bag. And on this tray, it will physically hold the items as they complete. The other thing we'll have on this tray is a receipt, but this is a special receipt. This receipt on the tray shows the details of the order, exactly what the order, but it's not the full receipt that you get. So it doesn't have prices and things like that. It is just like your order number and the list of items that you ordered. So I still have to worry about like, how do I coordinate completion here? So what happens when, in the picture above, one of these steps completes? So like the dress step completes. So the dress person places the item on the tray. They check the items on the receipt for doneness. And then they say, well, I don't have all the items on there. I'm not done. So I just go back to my station and do the next step. The next step completes. They place the items on the tray. They check the items on the receipt for doneness. And it's not done, so they go back and say, let's keep on doing other stuff. Now, the final step in the process that is complete, they place the item on the tray, they check the items on the receipt for doneness, and then looks good. And so what do? They call out your order number and say, order number 513, your order's up, ready to go. So this pattern is known as choreography. Choreography is initialized via events because I have multiple services potentially executing at the same time, but the key is that they're not dependent on each other. So I have an event-based initiation. The step order is not enforced in this kind of interaction. So things can happen before each other, after each other, at the same time. It doesn't matter. We're not coupling ourselves to that. However, because things can happen in a different order and complete at different times, I need to have some way of keeping track of what has been completed. And so that's completion is noted on that receipt. So as each person comes up, they look at the items on the list, they check them off and say, once everything's checked off, we're good to go. I also call this the observer pattern because we have a process manager that is observing all the different steps in the process when they complete. So the last step in the process is how do we deliver this to the end customer? So we need to have some ways to correlate the orders with people. And there's a couple different ways we can do this. One would be a natural correlation, that is to use your name. And you see this in coffee shops, for example, that they write your name on the cup, and at the end of the process, they call it your name, and it's supposed to be like kind of a more personal interaction. These restaurants don't do that, right? You're just another cog in the machine. So in that case, they'll give you a number as opposed to using your name. So they have an artificial correlation identifier, a number as opposed to using your name here. So this works well at the small, but what happens in larger restaurants, like a sit-down sort of restaurant? These restaurants have different constraints. So they're not trying to maximize the number of orders per hour because orders are much more complex. Instead, they're trying to maximize you sitting in a seat. That is, they want to keep you there as long as possible because they make the money on alcohol. So as long as you're sitting there and ordering more wine or beer or whatever, they're making more money out of you sitting there for a longer time. But it's more complex because now the food they prepare is much more complex, but they want to give it out at the same time. So I have to manage the timing of all these different pieces of food they get ordered. So I need to have a lot more control over this process. And so what do like larger restaurants do? They have someone yelling at everybody all the time, like where's everything, and making sure everything is getting done at the right time. So in this case, we have someone in the middle that's really managing all the different interactions at different times. And so this benevolent dictator, the chef, is really the one that's deciding when each step should happen. So in this case, they receive incoming orders from the waitstaff. They create a plan for completion about what actually needs to happen when, and they bark orders at people at specific points in time to ensure things get done at the right point to be able to be delivered to that customer at the right time. So again, it always starts off with a synchronous interaction. So I tell the wait staff what I want. They write it down, of course, but that communication with them is going to be verbal. And they tell me, okay, you want burger, fries, I got it. Some beer, okay. Now it's done, and I got to go tell the chef that it's ready. So the wait staff will let the chef know that now I have an order, and the chef can then look at the order and then decide how it's going to be fulfilled. So the chef looks at the order, decides on a plan for completion, and starts barking out the order. So they're going to tell the grill person, I need you to make this burger. Burgers take a long time to cook, so let's go ahead and get that started first. Now we want to get the drinks to the customer, so let's go ahead and notify the bar that we want to go ahead and pour the pint for that customer. The bar pours the pint, doesn't take very long, notifies the server that it's ready to go, and so the server tells the waitstaff to go ahead and then deliver that pint to the customer. It's good to go. Now, burger's going good, so now we have to worry about the fries. So the benevolent dictator tells the fryer to go ahead and make those fries and waits enough time to ensure that both of those things will arrive at roughly the same point of time. So in the future, the grill person tells the chef the burger is complete, puts that plate down. Next, the fryer tells the chef that the order is complete. Now the chef sees that everything is done and the order that they wanted it to. It's now they can say, let's go ahead and deliver that order into the customer. So this pattern is known as orchestration because I have, in this case, a process started off by a single message. So I said, place the order or the order is created, but I have like one single process that is managing all the other next subsequent interactions. This process manager uses commands to coordinate all the different steps in the process. So they will tell each person to do exactly what and exactly when to do it. We'll also use request response to indicate completion. So instead of the grill publishing a message for anyone to know, instead it's just telling the chef directly, like, okay, I'm done, and here's the rest of your stuff. So in orchestration, there's going to be a lot less tracking of individual status because the process itself is really managing the steps in which things need to happen by sending out commands and receiving responses directly. They don't have to have kind of state tracking to figure out which things are done and which things are not done. So just to compare the contrast, it's true. Like when will we choose orchestration over choreography? We need to look at the process flow and coupling between each of the individual steps to know like this step always happens after the other, or we need to make sure that this thing happens first before we can go on to the next step. So that means that generally orchestration is something I find inside of service boundaries, because inside of service boundaries, I have a lot more coupling that I'm trying to enforce. And so inside of service boundary, I'll have the kind of request response, command reply sort of interactions. And then usually choreography between our service boundaries. And the reason why we have choreography between our service boundaries is because we want to have a loosely coupled form of communication. And if I have someone directly telling each service what to do, then it introduces some process coupling because I know exactly what each thing needs to happen and when. So I'm really coupled to how each of the steps work. So let's go ahead and wrap this up. I'm going to skip the reads because we don't have quite enough time. And let's wrap it up. So some party thoughts here. The constraints of the real world haven't changed. The latency has just gotten much shorter. The solutions from the real world do apply directly to a distributed world. And a lot of the patterns and communication that we see are actually just taken one-to-one from the real world and just named and applied to the distributed world. And because the real world has solved distribution problems with messaging and communications and conversations, then we can too. We can take those exact patterns from the real world and apply them to our systems. So that was effective microservice communication and conversation patterns. If you want to read more about the subjects, you can look for the Microservices books. Those are great resources, as well as the Enterprise Integration Patterns book, which actually lists out every single pattern that we just saw today. So if you have more questions about this, I'll be hanging out in the speaker room, whatever, after this. Otherwise, I hope you have a great, I guess this is the end of the conference. So have a great rest of the day.
Jimmy, how are you feeling? The presentation is done.
Yes.
It's early morning. How are you feeling?
Well, I guess usually we would go up to the Sky Bar after this, but not this time, I guess. So
Actually, this time we will go to the virtual party, which Dylan is preparing.
Oh yes, he's always fun. I've been watching his music for gosh, it seems like years now. He's always a lot of fun.
Okay, so last year you have been in the conference, right? You have been in Skybar, right?
Yes, had maybe one or two cocktails up there.
Tea, of course.
Yeah, of course. Yeah.
Okay, so it was nice seeing you. I hope next year you will come to our lovely Lithuania, lovely, especially in this time of the moment. And thank you once again. And let's go party. Jimmy, for you, it's not still the morning, but we all are off to the party. So thank you and goodbye.
Bye, everyone.